Hello everyone, myself Paul One, Assistant Professor of EC Department at LJ Institute of Engineering Technology. Welcome to the session of Radar and Navigation of PLC. In the last session we have started unit number 4, that is MTI and the Pulse Doppler Radar. Eclipsing loss. Alright. Secondly, the degree of the eclipsing loss, it will going to be changed as the target's range changes with the time. So it will cause the eclipsing periodic holes in the coverage. Alright. Secondly, if you are going to approach a target which will not remain eclipsed for the long, so for detection it will occur at slightly a shorter range, which is eclipsing is present. So this reduction of duty cycle and increase in the number of range of target or range gate filter, it will reduce the effect of eclipsing. So what is the improvement over it? So if you are going to use the airborne AMTI, that means it have a low PRF. There are some different advantages. The first, there is a no range ambiguities, but there are a many broken ambiguities. That is called the blind spot. It requires TACCAR and DPCA to remove the effect of platform motion. First of all, what is TACCAR? So TACCAR full form is time average compensation for a clutter Doppler shift. And what is DPCA? There is a displaced phase center antenna. So what is the function of it? It operates at clutter free for the longer range, and in which there is a no clutter due to the curvature of the earth. Second thing, the side lobe clutter is not as much important as it is in the pulse Doppler radar. And the ergonomically can be employed at ultra high frequency. So the increase in the blind speed and the lower effectiveness of the platform motion compensation, we can also prevent it at the microwave frequency. So the lower radio frequency of airborne AMTI, which result in the wider beamwidth than the higher frequency if you are going to use the S band, okay, for the pulse Doppler radar, because whose mission is in the wide area air surveillance. As the beamwidth is broad, directivity is narrow. That means directivity is very less, alright, because both are inversely proportional. So there is a no range ambiguity to be resolved, because there are a redundant waveform with the multiple PRFs. So if you are going to compare the performance with respect to the product of average power and the antenna aperture, which is less than that of the pulse Doppler radar, it is comparatively simple than the pulse Doppler radar. Cost is generally less than the pulse Doppler radar. And the last, that is, the airborne AMTI can be used in interceptor, or we can say the band radar, X-band radar, for look down detection of target in the clutter. That means with the help of airborne AMTI radar, we are able to detect the target in clutter as well. Now we are going to compare the pulse Doppler radar with the AMTI. FR is estimated accurately. Over here, the range is going to be estimated accurately. If you are going to use a high PRF, it does not have any blind speed. But if you are going to use a low PRF, there is a no time around echoes. But over here, time around echoes is present. But in this, blind speed can be present. So we can use the delay line cancelers, and over there we can use range gated filter as well as a power amplifier with the high duty cycle. Alright, so what are the different salient features? So when the PRF is so high that the number of range ambiguities is too large, that is to be easily resolved, the performance of pulse loop radar which approaches that of the continuous wave radar. But the pulse loop radar has an advantage that detection performance is not limited by the transmitter leakage. So what are the limitations of AMTI? It has the improvement factor, that is a signal to carrier ratio for output to the input. So this is the average over a radial velocity of all the targets. Second, the subclutter visibility. To detect a target within the clutter of same power with a specific detection, it may cause the false alarm. Okay? And what is clutter visibility factor? It can be a signal to carrier ratio after a Doppler filtering. Clutter attenuation will be present at the clutter canceller. That means it is a ratio of input to output. What are the advantages? The multiple moving target can be separated from one another in the filter bank. And when the clutter and the target echo signal just appear in the different Doppler shifts, that clutter need not to be interfere with the detection of desired moving target. So, if you are going to measure a target's radial velocity, which can be obtained, so the ambiguity in the measurement can be resolved by changing the PRF. Secondly, we can also use a narrow band Doppler filter, which excludes more noise than do the AMTI delay line canceller, which we have discussed previously, and it also provides a coherent integration. Now, what are the limitations? As it is complex, the cost is also going to be increased because difficulty in achieving the filters with the low enough side lobes. Why? Because we need to reduce the effect of clutter, and also we need a significant numbers of pulse to produce desirable filter characteristics. The basic method for achieving this Doppler filter bank is we are going to use a transversal filter. That means a time delay between each tap of the transversal filter is T is equals to 1 upon Fp. Fp stands for pulse diffusion frequency. The amplitude weights at each tap are same. The first null of each filter are at the peak of adjacent filter. Okay. So we can say that the remainder of this frequency domain is covered by a similar filter but with the ambiguity and aliasing effect. So the lower side lobes are needed. Why? Because we require a large value of improvement factor to be obtained with the Doppler filter bank. So the main response is going to be widened, and we are not getting any peak gain because it is going to be reduced. Okay, the filter crossover is less. So for that, The filter bank requires a more pulses for the good performance, and also it requires a larger signal to noise ratio if we need to extract the radial velocity for more than 2 PRFs. So what are the limitations to the MTA performance? Limitations are: first, the antenna scanning modulation, internal fluctuation of clutter, equipment instabilities, and because of the limiting amplitude. So what is the effect? Because of this limitation, the clutter spectrum is going to be widened, and that more clutter energy is going to be passed through the Doppler filter, alright, which lowers the improvement factor. Alright, so over here we have discussed the MTI, L1 MTI, pulse radar. What is a difference between pulse radar and MTI? Which one is more efficient? What are the different disadvantages and advantages? How to overcome it? And if we are going to overcome it, which components or which devices are going to be used? What do you mean by stereo? What do you mean by combo? That we have discussed for the MTA. Okay? But still, if you have any doubt, you can ask me anytime on my video email ID. Till then, thank you for your attention.